We were kind of talking surface level about some of the stuff that people probably grasp and can understand. What are your ideas for some of just the crazier ones that you bring up in meetings or talk about, and people are like, "Whoa, Matt's got his tinfoil hat on," or like, "That's way too far out there." Any use cases that come up in that regard?
I mean, there's lots of companies that are working on this and they're making really great progress on it. But I do think any physical progress will be completely able to measure and calculate using these technologies. And you'll just get a report that says, across your WBS, here's the % complete on all of your work packages. As long as it's a physical thing, right? You need a thing to see. Like, it's not going to help you measure like cable pulls and commissioning tests. But I think that is 100% completely automatable.
Welcome to the Beyond Deadlines podcast, where we tackle challenges that planning and schedule leaders come across on a day-to-day basis. My name is Micah Piippo, and I'm a scheduling manager for Intel.
My name's Greg Lawton. I'm the CEO of an AI schedule management company called Nodes and Links.
And I'm Matt Craske. I'm the head of project controls for Google.
Today, we have a special episode for you. Matt joined us a couple weeks ago, and he dropped some serious digital knowledge on us, and I'm sure you're craving more because we were after the episode. We touched on a subject called computer vision, and we just started to scratch the surface of it, and we want to dive more back into it. Use cases and how we can use computer vision to elevate construction portfolios. So Matt, maybe kick us off a little bit with refreshing the audience. What the heck is computer vision, and what the heck were we talking about? And then we'll just jump off from there.
Yeah, so computer vision is really almost the analogous to human vision. It's the ability to teach machines how to see what we see. And they do it very similar to how we do it. They see an awful lot of examples of something, and you tell it what that something is, and then it recognizes that something in visual data at some point in the future when you ask it to. I think the reason why this is very interesting to construction is that an awful lot of what we do is visually based, be it reading a document, like visually verifying that something is or isn't there in the field, checking safety behaviors, checking security behaviors. They're all done through a human looking at something and then recording that thing so that you can then trend it or review it or analyze it later. And so if a machine can see those things and recognize those same things, you can have basically the same workflows that you have right now, but you can automate a big chunk of it, or you can go kind of belts and suspenders, right? And like, we'll probably get into this if we talked about safety use cases, but wouldn't recommend that you replace safety observations with computer vision observations. But a computer can see a job site 24/7, 100%. Humans can't.
Yeah, no, I completely agree. And so just to reiterate why you're bullish on this, you have the automation piece, which is obviously cost savings. You have the elevating of other people's work on the safety and some others. So you're basically bringing along and upskilling other individuals. I think you have the opportunity for future optimizations that humans can't consider. Even if you have a P6 schedule with 15,000 activities in it, optimizing that for your workforce and your long lead equipment and everything can be a challenging thing. Anything else that I am missing there? I'm sure there's tons, but why you're super bullish for this?
I think the last one would just be that the vision would be superhuman, right? So a machine can see things that we can't see. So machines can see in infrared. Machines can see in incredible geospatial accuracy through point clouds. And so you'll be able to see things that you can't currently see by using these technologies. I think lastly is that most other industries have already gone in feet first with these technologies. Consumer electronics, if you buy a consumer electronics product, I would guarantee you that there's been some form of computer vision based quality check done on that product. Automotive, they use tons and tons of computer vision to make sure that your car doesn't fall apart. And so if all of these other industries can do it, why can't we?
So in consumer electronics and automotive manufacturing, they run very repetitive production lines. If if one of our listeners was thinking, but my project is really unique, how would you get computer vision to start to understand and to be able to process some of the unique aspects of those projects?
Yeah, a really great point and great question. And in fact, I would say that myself, is that like construction is a much more noisy environment than a car manufacturing line or a consumer hardware manufacturing line. And so I do think you would have to go slow and point it at the right problems, right? But I think we would be amazed at how quickly this is going to move. So, for example, we've been looking a lot at video analytics. So using low-cost camera networks, think more of a Nest Cam than a $3,000 PTZ, right? It runs on batteries, communicates over mesh. Any idiot like me can install one. If that's looking at a scene, it can look for like objects, like is there a forklift truck in the image? It can look for like proximity to danger. Is this thing close to this thing? And we don't want that to happen. It can look at how things change over time, potentially for progress use cases. There's all kinds of things that camera can pick up, and we'll get better and better and better at like being able to analyze it all on the back end to see what's going on. So yeah, I completely acknowledge and admit that some of this stuff is going to be really difficult and really noisy, but if you pick the right use cases, I think there's an awful lot of things that already work basically out of the box.
Yeah. Spills, PPE, lockout, tag out. I mean, the stuff that cameras can already pick up. And isn't there also out of the box vision-based models? I thought I was seeing on AWS they had, and I'm sure Google has some, and Azure has some.
Most of the hyperscalers do offer like what's sometimes referred to as a model garden, where people will train computers to understand something in image data, so like an object, and then they make that available to everybody else for them to use. So like Google's got like a car counter. It can count how many cars go in and out of a known area. It can also tell the speed of those cars. And so like on a job site, you could potentially use it for traffic controls, right? Traffic controls on a job site are kind of inefficient in that it requires a lot of people to stand around with signs. Right? There's a whole world of opportunities that you could do with traffic control related to that.
And I like that these technologies seem to be able to also attack small use cases. And so they don't need to be this. I think that's one of the things that I noticed working with construction companies is everybody wants these like silver bullet, gargantuan, this will fix all problems everywhere. And you end up in these year-long implementation cycles. And it just, by the time you get there, you're like, do we even actually improve anything? And it seems to here, like with the cameras, no, you don't have to put a camera everywhere and track every single thing. You can just pick, here's a use case we're interested in, cars driving too fast, throw out some cameras, boom, you're done. Let's move forward. And then you can keep going and find other solutions.
Yeah. And I think it also gives you a level of like retrospective to things that you just can't do with people. So kind of picking on safety again, a lot of safety observations are second and third hand accounts, and it's what that person perceived to have happened rather than what actually happened. Right, which is like fair enough, but the camera won't lie. It will give you exactly what happened.
I've watched enough Dateline to know the first-hand accounts you better watch out for.
Yeah, and you got to get to root causes and change things that you probably wouldn't do normally. So for instance, if you were trying to monitor 3 points of contact on a major entry step, and you were seeing lots of people weren't using 3 points of contact, but you didn't know why. Like, is it because they're not trained very well? Are they not aware that we've got a policy around 3 points of contact? Do they not know that that's a key safety behavior? Well, maybe it's just because they've got their phone out and they're checking their emails as they go down the stairs. And so your root cause is actually about phone usage on the job site, not stair usage on the job site. And so I think it's going to allow you to do things like that and get to real root causes in a way that kind of human observations just won't be able to help you get to.
Yeah. And then you wire up a little robot at the top of the stairs when the person comes by with their phone and says, put your phone away for safety.
Yeah, there's definitely a lot of privacy concerns related to things like video, but I think even use cases like understanding documents, right? There's so many workflows in construction that still require dense documentation. And I think people think that a PDF is like somehow a digital document. Like, it is in the sense that it's a digital file, but you know nothing about what's in that document. So it's just a 24 meg file sitting on your computer. Whereas computer vision and OCR, ocular character recognition, can help you understand everything that's in that document without you ever having to open that document.
Compare it to documents very, very quickly.
Yep, compare documents. There's a thing called key value pairs. So if you're interested in two things in a document, so say profit percentage and the value of that profit, you can scan all of your contracts and it will create you a database of all of the different profit percentages that you've got across your portfolio or your program. Spec checking as another one, legal contracts. There's some workflows that you probably actually want to leave them as handwritten, because the kind of handwritten nature of them is the benefit that you capture that information there and then. But you can then consume all of that handwriting, understand that handwriting, and turn it into database information rather than a piece of paper that gets lost on someone's desk.
So computer vision, based on all that, computer vision is essentially going to allow us to what I call recapture things either outside in the real world or documents or things that we've got even digitally, because you shouldn't really be printing out documents nowadays. That implies that companies that have never engaged with this kind of activity are going to be generating enormous levels of data, which will require them to be familiar with data lakes, and there'll be costs associated with storage of all of this, let alone compute. How big a transformation are we actually talking about here? Because we talked about we could start off on small beginnings, but is this going to quickly hit the CFO's desk for a multi-million-dollar storage bill?
Yeah, I think some forms of data are obviously more expensive, right? Videos, point clouds, they're incredibly large files, but I think you'll see those files reduce in size reasonably quickly. I do think there's various things you can do with encoding, etc., to get that kind of data usage down. I do think you will also not be storing it all. I think people have this view of like, what am I going to do with petabytes of video of nothing happening during the weekend?
Yep.
This is where I think you would have kind of analytical tools that chop out only the things out of that video information that you think you're going to be interested in, and it deletes off everything else. So like for video, if the image basically doesn't change, it will chop out all of that and you really won't store it. You'll just clip out the things where there's interesting stuff and you'll only be storing that. And I think also you will probably get to a point where you only ever actually store like the metadata of that visual data. So like, if you like go back to the video use case, like let's say you're counting cars, you'll just have the table of how many cars were counted. You wouldn't have the video of cars going by. Like, it's video of cars going by is not interesting, but you do need to know how many cars go by. So just record that, put it in a table. Like, that type of data is basically free. I think also like storage costs have dropped dramatically, and they'll continue to drop. So petabytes worth of information these days is not gonna like break your IT budget. So that's a few things I think will go on with that kind of storage. I agree with the concern though.
What about the also? I mean, I saw this with just the specific progress companies. Most of them started out saying, "Oh, we're going to use LiDAR and 360 photos," and then as the software actually improved, you saw LiDAR shift to the backseat because they didn't actually need that high fidelity of photo or of mapping of the site. And they were able through software to continue to reduce that intake. I mean, is that probably going to pan out like that computers are just going to be able to do more with crappier cameras, basically?
Yeah, and I think it's also getting into the details of the use case. So, like, if you really need to understand something down to centimeter accuracy, like you do need a point cloud that is not noisy. But there's an awful lot of problems in construction that aren't centimeter accuracy type problems. I think there's also an awful lot of things in construction that are just simple, like, is it there? Is it not there? How many of them are there? How many were there last week and how many are there this week?
Yeah, both Micah and I are laughing at this.
An awful lot of it is just counting things. And so I think you've got to use the capture technique that has the accuracy for your use case. But I do think you're right, Micah, that like what's possible with photogrammetry these days is incredible, especially with real-time kinematics. Like photogrammetry can get down to basically centimeter accuracy these days. So I think you'll get both.
We've also got to remember that the actual cameras themselves are going through their own spiral development, where costs for them are crashing whilst quality is going up. So if you think about like DJI cameras now compared to drone cameras 5 years ago, it's a completely different ballgame. I think this asks a question, Matt, which a lot of project people might be thinking here, which is, I haven't trained for this. Like, this is a different world. Like, the project controls principles are generally holding the same, but this is not Excel, and this is not the normal systems like Primavera that I'm used to. You're talking point clouds and computer vision and magic words. Should I be scared?
Does PMI have a certification for this?
I think, to be honest, people already do this stuff. They just do it like manually rather than leveraging what's possible. So I don't think the data really changes. It's like how that data is generated that's changing. And then I do think a lot of these stuff, the user will never know that it's there. Like you'll just get a report each morning that says there was these safety incidents, these near misses on your job site last week, yesterday, and use this information to go do toolbox talks today about like what needs to be fixed. Or like on the point cloud stuff, you'll just get a report that says this amount of your slab in section 2 was pumped, placed, and finished yesterday. And you'll just use that in your EVM calculation or to status your CPM or whatever else. Because someone's already doing that. Like someone is measuring that concrete. You're just
supposedly.
Someone's
supposedly doing it.
Yeah. Well, I think that's another thing. It will open doors to measure stuff that we don't measure currently because it's difficult, it's laborious, it's very short time windows, right? Sometimes things happen in the space of a few hours. No one's out on job sites status and schedules down to that level of detail.
Yep.
Do you see where my brain always goes with this is like, if we're in, phase 1, phase 2 is this kind of like propagating and becoming a big deal. Is phase 3 then, as you start to get these sorts of different data sets, like you said, counting cars, and that's to me is like, if you're doing the predictive or the calculation part, is phase 3 just this wild utopia of actually predictive data? So based on like a couple cars drive into site, you're like, I know we're going to have a speeding problem. Or based on like a couple people on the stairs, you're like, we have a point of contact. I mean, is that's where this is going to just drift into, where then people are going to create the predictive models to try and help solve the problem ahead of time?
Couple of cars come to site, and I haven't seen enough of our site. I haven't seen enough of our electrical engineers turn up this morning, so it's definitely not getting commissioned by the evening.
Yeah, so there's an awful lot of technologies that are all kind of converging, right? So low-cost camera networks, mesh communication networks, computer vision, but also what's going on with kind of machine learning AI capabilities. And so a lot of what's possible with machine learning requires higher frequency, higher volume data inputs for it to make decent predictions about the future. So I do actually think they're complementary, that if you can get higher frequency, higher volume data coming off your job sites, and you train models on what those things typically mean for a project, it will be able to predict kind of quicker and sooner a problem than like a human could, because we're kind of working in like daily, weekly, monthly type cadences. This stuff could potentially work in hourly type granularity.
Yeah, because when we were working together, Matt, one of the analysis we would pay to have done is like a time on tools analysis. So how close are the tools to the workers, and how much time do they take to go grab them? And then how much time are they spending with those tools? And there was always a little sense of bias that happened with those analysis, because the people know that that's going to happen. There is, a recording that's going on, they're measured, and then you only get a very small subset of data. And that's where it was something, as you start to expand on computer vision, I mean, that time on tools has been shown to be an effective measure of productivity. Being able just to have that, it's like just free, like this is like, you probably can then extrapolate that out on, this is what our productivity is going to be, and this is where our schedule is going to finish. And then we really need to fix that time on tools.
Yeah, couldn't agree more. I mean, we obviously need to be careful about privacy in all of this, right? And that should be back at the forefront of everybody's mind as we're implementing these types of things. But yeah, what you can do around time and motion studies, understanding waste, as I mentioned before, really get into the root cause of what's going on. Because like sometimes people assume it's like, oh, just the labor's inefficient. Well, like, why are they inefficient? Are they lacking material? Is the material staged too far away from their work face? Do they not have the tools that they need to do the job? Do they not have the information that they need to do the task? Are they missing some checker in the system that the thing can't be completed until someone's checked it? So they might have done the thing really well, but then you waste time waiting around for someone to look at it.
And then the one that they've checked all those boxes, and really there was a person who just didn't give them, the scope is too big for the time allotted for the task. And so the labor is actually perfectly productive. It's just you were crap at estimating what the time of that labor or what that activity should have took.
Yeah, no, couldn't agree more. So yeah, I think it's just an endless number of use cases.
What are some of the wilder use cases? We were kind of talking surface level about some of the stuff that people probably grasp and can understand. What are your ideas for some of just the crazier ones that you bring up in meetings or talk about, and people are like, "Well, Matt's got his tinfoil hat on," or like, "That's way too far out there." Any use cases that come up in that regard?
I mean, there's lots of companies that are working on this, and they're making really great progress on it. But I do think any physical progress will be completely able to measure and calculate using these technologies. And you'll just get a report that says, across your WBS, here's the % complete on all of your work packages. As long as it's a physical thing, right? You need a thing to see. Like, it's not going to help you measure like cable pulls and commissioning tests. But I think that is 100% completely automatable.
I would actually go back, Matt, and you and I know that commissioning and cable tests and these things are always accompanied with documentation. So technically, if someone signs the documentation on their tablet, technically because this was actually one of my biggest bugbears when computer vision really started coming into construction. It was mainly about the overselling of by vendors around it, in that you can track all progress. And I was like, but a lot of progress is actually document progress. Can you do but now with Gemini and those kinds of technologies, I'm actually starting to think maybe the progress report is whatever I make it. Maybe I just ask, please give me the S-curve, the key activity list slip, and if anything's slipping, tell me why. And you can literally show me a picture of why it's slipping. It's like Micah having a coffee whilst he's supposed to be like delivering cement or something. Like, Micah, get driving.
Back to the privacy concerns. Micah doesn't sign the waiver to be on camera. Now he's tricked the system.
I do think things like that are going to be possible. I think you'll be able to do a natural language communication with something like Gemini and be like, hey, show me that trench that we dug in the northeast corner of the site back in last November. I don't know if we put in like X amount of rebar. And it will be able to recall some information for you, either data or even some visual information. You'll be like, oh, no, actually, that's all good.
Oh, that's a good one, because it's like, hey, we're going to go dig a trench here to add in a new underground line. Tell me if there's anything that is there. Now, obviously, someone's going to go look through the model and check and do some, but it's like another re-verification of site photos and site videos. That's a good one.
Do you know? I'll say something that I'm really excited about with this, because actually I completely agree with what you said today, Matt, and the other week. The thing that I'm very excited about is the simple learnings that we'll do that you can't otherwise do. So, for example, like people do elements of this today. Obviously, 10,000 people walked down the steps, 5 people fell. No one's been injured. Still 5 people fell. So we know that the steps are dangerous because of some reason. Now, they could have been on the phone. But for example, things that people don't do, every time we've dug a hole, it takes 7 days rather than 5. Why? Just stick it as 5. It's like, well, how about we find out? And then you go into it and you're like, actually, they're digging through clay. We thought it would be dirt, and clay's much harder to dig through. Okay, well, maybe actually we need to start doing site surveys ahead of the line or something like that. For me, I actually see a massive boon in productivity in construction because people will learn simple things.
For sure. And I think that learning will be across disciplines. So I think you might have some listeners that are hearing some of this and they're like, well, I'm a surveyor. I know exactly what rebar went into that trench, right? But for the scheduler to know that, they have to talk to the surveyor. Like you've got this big chain of people that need to transfer knowledge to each other for you to get a complete picture on a job site, to understand things that aren't necessarily like their SME and or like the data that they typically work with, but they still need to know it because it intersects with what it is that they do on a job site. And schedulers are kind of often a key part of that. Like, I think it's unreasonable and impossible for a scheduler to understand like all the little means and methods and how something happens and what's productive and what's unproductive to really get all of this stuff as accurate as we would like it to be. And so I think we look at like schedule data as this like highly empirical thing, and I'm not sure it is, and which is fine, but you can now get into a layer of information as a scheduler that you really wouldn't have been able to do before.
Which then brings up questions about tool sets. And, can tool sets go down, current tool sets go down to the level of detail that we're going to start being captured? I do a lot of work on predictability. And, you get to the point where you've figured out the things that are driving unpredictability in the schedule. Then you're like, why? And that's when it ends. That's where everything ends now. It's kind of like, okay, well, I don't know. You're going to have to parachute someone in and find it out yourself. I can't wait to the day until you can go, oh, and because of this. Like that will be an incredible day.
You touched on something that I think is one of the key benefits of this is the retrospective nature of it. So Micah touched on it a little bit with like understanding what was put underground 2 years ago. But think of something like, you buy a project, maybe a manual transfer switch, no, an automatic transfer switch maybe, right? And you start to see failure rates across your fleet for this particular product that you don't know why. Like computer vision can help you go back in time and work out what happened to those automatic transfer switches and really get to the root of why they might be failing to help predict which ones might be failing in the future. Like being able to do things like that. I mean, like companies spend millions of dollars for like trying to fix systemic failures that they only find out after several years of operation.
Yeah, ripping it all out because you don't know, and you just got to rip it all out and put it back in new. I mean, that is billions of dollars.
And you've got no idea what your actual failure rate is. You've got 10,000 of them in population, and you know that 100 of them have already failed. Do all 10,000 fail at some point? How do you know which ones are good and which ones are bad? Being able to go back in time and see like the genesis, the root of that issue, so you can better deal with it today, I think is going to be like invaluable, especially as our buildings become more and more and more complex.
It'll be dangerous for some people because, Greg and Micah's chop shop, you're going to find out that those 100 were put in by us. And then, then we're going to be in trouble.
Greg, we should sell that shop quickly. Going back just a little bit, some people have said, oh, well, this is going to make people not communicate as well, or not be in the construction site or in the office, or, either way, not be able to, collaborate more. But in the example that you brought up about the site surveyor and the scheduler, I actually see this as like boosting both of their knowledge sets up. And then they actually have more thoughtful, better collaborative approaches because the scheduler understands the site survey a little bit more and the site server can kind of understand the schedule data a little more. And there's just overall better collaboration.
Couldn't agree more. And I actually think that construction should think more about kind of remote interaction, right? Because you want to have access to all the best information and all the best people, but having all of that on site at the point of work is really, really expensive and usually really slow. I think we talked about this with like a quality workflow, right? If you're an electrician and you do a piece of work and then you're waiting for your supervisor to sign off on your piece of work, and then the third-party inspector has to also sign off on it, you could have done your work and it could be weeks until you find out whether it actually passed. And so you don't get an opportunity to fix unfound. You don't get an opportunity to learn in the moment to make sure that you don't do it again. And you have to get recalled back to come fix it. So a workflow like that has some sort of remote interaction, right? Maybe the third-party inspector can be back in the trailer or even off-site and can get engaged in that quality workflow, even though they're not there. Like huge time savings, loads of doors are opened up for, again, fix on found, learning in the moment, all of these great things.
I'd actually like to see it taken further, and I'm going to try and coin something here. It's what I call is roll to code. So if people have to be in physical presence, there's a certain limit to scalability. To your point, if people can be digital, you get an increase to scalability, but someone can only be on one call, should only be on one call at once. But if people are able to leverage, some of the more advanced models today, and essentially you replicate the person, that means that you could have 10 Matts and 10 Micahs, or you can work asynchronously, where, you're having asynchronous conversations. I think that level of scalability is actually something that this industry hasn't even thought about before.
Yeah. That's kind of connected to something we talked about before again, which is like codifying knowledge, right? Turning tacit knowledge, right? You've got this 30-year veteran electrician. They're amazing. Their quality of work is incredible. Like you've got to have that that person on your project to kind of increase your chances of success. But they can only be on one project at a time.
Exactly.
And they're going to age out. And they might not have transferred all their knowledge on, right? And if they have, they've like manually transferred it on, most likely. Like nothing fundamentally wrong with that, but this opens the doors to codify that knowledge of that amazing electrician and make it available to so many more people in a much more intuitive and useful way and at point of use. So let's just say they're like experts in medium voltage terminations. Right. If we can codify what they know about what a good medium voltage termination looks like and train a machine to understand it, I can now basically have an infinite number of those amazing veterans.
Mm-hmm.
And I don't think that should be seen as any threat to anyone's livelihood, to be honest. I know it's easy for me to say, like standing here, but we've got a shortage anyway. We've got a generation gap, right? We've got more people kind of aging out than we have coming in. We've got a knowledge transfer problem. And I think if we really are serious about building what everyone wants to build around the world, I think you have to address things like this. Or otherwise job sites are going to become more and more unsafe. Quality is going to continue to be a challenge. Costs are going to continue to rise in ways that like make some projects untenable. And obviously, schedules are going to go out the window.
Yeah, I really see that though as like improving the skill. Like every time this gets brought up, there's this like people go to the Skynet so fast of like Terminators are here. Greg usually brings up how everyone's going to be murdered, so I'll take that's one for you.
Haven't done it this time. I haven't.
I'm taking it. I'm instead of taking it for you, but people go to this like Skynet. We're like, oh, robots are everywhere doing construction jobs. But there's this whole middle ground of no, this actually is a very great skill set that can uplift the current worker base that may be missing the skill set, and they can use this as a tool to learn and grow and go faster and be more productive. And it's really just going to elevate that, worker we already have, the workers, any of them, office or in field. And I would see that is really probably the next 10 to 15, 20 years, because I still feel you're pretty far off from the Skynet so far. And even if you're going there, it'll be a nice growth transition for those people anyways to get to maybe that more autonomous world anyways. They get to grow along with it. So yeah, I mean, I always see this as like a great ability lifter as opposed to a stealer.
Yeah, I mean, like going back to that quality workflow, like the ability to see a problem in like a medium voltage termination, right? It can potentially save lives, right? Like arc flashes are really, really serious problems on job sites, right? And so why wouldn't you want belt and suspenders? I think also it will be used to help you do better manual checks. That will be the first iteration of it, right? So let's just say we've photographed and used computer vision on every single medium voltage termination on a data center project, right? There'll be like 1,000 of them, right? Someone has to go check some amount of those, double check it, right?
Mm-hmm.
So some form of sampling. So they randomly pick some. Well, what if we could focus them in and have them check the ones that we think there might be a problem on, right? That is fundamentally better in my mind.
I also see an element of kind of honoring the previous generation, because the people who've worked for 30 years to get that level of knowledge, it always seems such an enormous waste when those individuals are sent off with a kind of little glass circle saying celebrating 30 years, and then they're kind of disappeared. I think, in the last 6 months of their career, if the whole thing was to kind of honor everything they've done and recall all the stories and get them to teach lessons and go through all of this, I think that's a fantastic way to better capture human experience. I mean, people might be thinking about this, well, it could take elements that I do in the future. I'm kind of thinking out the other way, which is, why would you waste 30 years of someone's past?
Couldn't agree more. Just this ability to codify knowledge in ways we've never done before. I think we should look at it as just a huge opportunity. because there is so much knowledge out there, and we are losing some of it.
Mm-hmm. And I don't think it would be a far sight to believe that, which companies move quickest on this and which companies actually are able to do it properly. They're going to win the market. It's going to be as simple as that, really.
Yeah, I think we should think about more people in construction as knowledge workers and treat them as such, right? And how do you turn their tacit knowledge into codified knowledge? And how do you turn that codified knowledge potentially into IP, right? So if you're a construction company and you've got that amazing veteran electrician, how can you turn that knowledge of that individual into IP that you can kind of use on future projects and take advantage of? I do think that is going to be a real competitive advantage for some companies that embrace this.
Well, whilst you were talking this episode, I was already thinking about could you go to the venture capitalist, raise a fund, hire these people, give them a year's wage for 2 months' work, capture all that knowledge, and then turn it into a massive IP database, and then sell it back to the companies. It could be done. By the way, anyone listening to this, do it.
Chop Shop is back in business, baby. Greg and Micah's Chop Shop is back. We went out of business, and now we're back at the top, all in one episode, folks.
Yeah, I would say my desire is to try and make the construction industry better overall, make it safer, make it more productive. I think automating away electricians and plumbers is not where we should be focused. I think there's so much we can do in the kind of more management layer of construction to be more efficient, to be better planned, to enable tradespeople to do awesome work more. And I think there's this view that tradespeople should move up into the management layer. And I actually don't think we should kind of promote that idea. I think they're way more important and valuable than we are. And we should kind of get our stuff in order.
Do you know, I agree with you there. And actually, do you know what I find really, really intriguing? In a lot of the big tech companies, if you're a developer, you don't have to go into management to get promoted. There is a path to the same level of earnings potential, but being an individual contributor. But in what I call old construction companies, they don't do that. You have to go into management. And obviously, the reason is it's a scale problem. As in, if you're an individual contributor, there's only so many welds you can make. But if you're running a team of 10 welders, you can scale. But when you're talking about, if you do consider people knowledge workers, then you can scale knowledge. So I think that's a very interesting way of thinking about it, actually. Like designing paths to expertise, not paths to management.
Yep, exactly. Yeah, and I think, obviously a lot of this will rely on training data, but I think you can basically create training data for free in our current workflows. Right?
Oh, yeah.
Like someone taking a photograph of a medium voltage termination or many photographs of medium termination is not a particularly large overhead, right? And their supervisor is checking that work anyway. So why don't they just check the photography and annotate?
They might even be taking a photo already. You're just not using it. Yep. How many times, Matt, would we find use cases where we're taking photos, we're taking videos, and it's just not being used?
Yep. And taking loads of photographs during your training programs, because the machines actually need to understand what bad looks like just as much as they need to understand what good looks like. And I think you can create all of this training data, this knowledge, just with our current workflows with some very minor changes.
Beautiful.
Folks, that was hot. There were lots of golden nuggets in there. Matt, any final thoughts outside of we should all get tattoos that say computer vision on it?
I think just start collecting a lot of visual data on projects. You might not need it today, but you will need it in the future. And that data is going to become your knowledge, and you're going to use it as training data. So I just think the more visual data we generate on projects, the more doors that open up for the application of these technologies.
And I would say on an individual level, it is very easy to go test and pick up the software and then try it out yourself. I mean, there are easy to learn courses that Google, Microsoft, AWS offer. It's easy to go experiment and tinker around in these and figure out some of these solutions ourselves. I mean, going back to a couple of years ago when Matt and I were working together, we had an individual teach himself how to actually build a photo comparison app on a couple pieces of work we were using. So this is not impossible for you to go do. This is not hard for you to go do. Roll up your sleeves, go find that thing you're passionate about, whatever that use case is, whether it's progressing or safety or whatever. Follow your passion, and then you just start building from there. There's a gazillion resources online as well too. So on a personal level, definitely dive into that.
Yeah. Most of these tools are low code, no code.
Yep.
You're drawing diagrams. You're not writing in Python.
Absolutely. Listeners, audience, thank you for coming in and joining us this week. Before we take off for the week, if you could do us one big favor outside of going and learning computer vision and saving the construction industry, share this podcast with your friends. You have to know one coworker who could be interested in this. Please share it with them. We're trying to grow the audience and help us provide you bigger and more value. So for us at Beyond Deadlines, we'll see you next week.